Hello friends, we will continue our series the concept through the questions. Today's question is on your screen. In given question there is a two plate, the upper plate which is fixed and lower plate is moving with velocity 0.3 meter per second, and there is another plate in between the two plate which is moving 3 meter per second towards right. Then the fluid or oil which is in between the plate which has viscosity which is 0.27 Newton second per meter square. Now we have to determine the location where the oil velocity is 0 and the force needed to maintain the motion. So first we draw the velocity profile. The upper plate which is fixed, so the velocity will be 0 and this increases in this direction, and lower plate which is moving with velocity 0.3 meter per second, that is in this direction, that is towards left, and the upper plate which is move opposite toward the lower plate, that is this one, this plate which is shown by red line and the shown by blue line. These moving with opposite direction, and this one moving 3 meter per second and this moving with 0.3 meter per second. So the velocity profile looks like this is this way. This is in this direction and this is in this direction. This is the point A which is velocity 0 velocity. So here velocity will be the 0. Now these are two similar triangle, that is this one and this one. So by the similarity, velocity profile is linear as given in question. So by similarity, the h2 minus ya divided by ya is equal to the v by vm. So again if we substitute the values, so this is 2.6 minus ya divided by ya, this is 3 by 0.3. We get ya is equal to 0.236 meter. So at this location the velocity will be the 0. At this location velocity will be 0. Now the second question, which is says the force needed on the plate to maintain the motion. So the plate is moving rightward, so the shear stress which is act towards the left. So this is Fs top side and this is bottom side. So shear force acting on upper side, this is say tau s top side or upper side, which is the This is the mu b minus 0 divided by h1, which is the 0.27 into 3 divided by 1 into 10 to the power minus 3, which is 81 Newton per meter square. So shear force this is Fs, this is upper side, this is the 81 into area, which is the 0.3 into 0.3, this is 0.3 into 0.3, this is the 7.29 Newton. Now the shear stress on lower side, shear force on lower side, this is Fs lower, which is the tau s lower side into area, which is the mu v minus vm by h2 into area. If we substitute the values, so this is 0.027, this is 3 minus 0.3 divided by 2.6 into 10 to the power minus 3 into 0.3 into 0.3, we get this is 2.52 Newton. This is shear force on lower side. So total shear force, or force to maintain, force to maintain the motion, which is the F is equal to the shear force on upper side plus shear force on lower side. So this is the force which is need to maintain the motion. So this force, shear force, which act in opposite direction, so this is F is equal to the Fs upper side plus lower side, which is the 7.29 plus 2.52, so this is the 9.81 Newton. This is the force which is needed to maintain the motion of the plate. Thank you.